Let's talk about objective 111. Solve a quadratic equation by factoring. Now the difference between 111 and 110 is very small, and what you're going to see is we're going to work down to the very last example, where the last example is going to be an ugly mess. But
yeah, I can't figure it out.
Some of these, though, are exactly like what we did yesterday, if not even easier. So solve a quadratic equation by factoring. So you should know just from that title that you're getting ready to see a quadratic equation. So here's a quadratic equation. I need to know a couple things. How is your brain going to register that the thing that you're looking at is a quadratic?
It has an x squared.
Has an x squared. And then it's an equation because of what?
It has an equal sign.
Has an equals. So that's how you know what you're looking at is not just is it a math equation, it's actually a quadratic equation. One thing about quadratic equations, as you can see, I got 3 pieces over here on the left side. A quadratic equation can only have 3 different types of pieces, tops. It can't have 4 different things. It has x squared, x, a number, and that's it. You don't have to have all 3 pieces, but the most that you could have is these 3. You could just have 2 pieces, and you've seen some of those yesterday. But let's look at these ones. They're all going to have 3 pieces, and I think on this objective, they're all going to be on the left side anyway, so that's good. X squared plus 13x plus 42. What we want to do is take that left side, take that trinomial, and factor it, which means factoring means unfoiling it into 2 binomials. The good thing is x squared does not have a coefficient on it.
So you just bring the x down.
Yeah, so I just put x and x inside that parenthesis. If you don't have a coefficient, that's good. You can just drop a couple x's in there. Now I'm going to try to find 2 numbers that multiply to what? 42. I need 2 numbers that multiply to 42.
7 and 6.
Because they have to add or subtract to what?
13.
13. So there's a lot of ways to get 42. 42 and 1, 21 and 2. But the ones you want need to add to 13. And a lot of you kind of got it first guess. It was 7 and 6 or 6 and 7, either way. So I put those in there like that. All right, now that I have unfoiled it into these binomials, I've got the first binomial times the second binomial equals, since the first binomial times the second binomial equals 0, what I'm going to do is set this equal to 0, and then set this equal to 0.
It just becomes the opposite.
And it just becomes the opposite, and that's going to happen a lot. Not every time, but a lot, that's what's going to happen. So this becomes x equals -7, and this becomes x equals -6. So your 2 answers are, one of them could be -7, or the other one could be -6. That's how we did it. Take that trinomial and unfoil it, and then set each binomial equal to 0. This one's pretty similar. Let's go ahead and put these binomials. Now notice the trinomial on the left. Does it have a coefficient?
No.
Yeah, no, it does. So remember, it's better for us if it doesn't. It will at some point, but.
The second you said about a quadratic.
Oh yeah, it's quadratic. Yes. Does this have a coefficient over here? No. So that's good. That means what can we do?
Just bring the x's down.
Yeah, put x and x into your parentheses.
It was quiet for a minute too. Everybody's just sitting there.
Yeah. No. All right. So now I need this one. I'm not going to even write down. I need 2 numbers that multiply to 9. Yeah. And my 2 options were 9 and 1 or 3 and 3. Which one am I going to go with?
3.
3 and 3. Because what do I want them to do?
Equal -6.
-6.
So negative, or -3 and
-3 and -3. This is a little bit different than what we've seen at this point. You notice these binomials are the same. If I set this equal to 0, what's it going to give me? 3. If I set this one equal to 0, what's it going to give me? 3. So I'm not going to say my answers are 3 or 3. I'm just going to say I have one answer, and it is 3. If they work out to be identical binomials, then you're really just going to have one answer. X is 3, or x is 3. So it's just one x is 3. All right, here we go. Here it gets ugly. Why? What makes this a little bit more ugly than the last one?
It has a coefficient. Oh,
Yeah.
okay.
This coefficient. Now it's ugly. So here's what we're going to have to do.
Berry method.
Berry method. So in the Berry method, instead of dropping x and x, what am I going to drop in there?
4x.
Yeah. And I kind of already have that part done for you.
You're so kind.
Yes. Now, last time we just looked at this number and I said I need to multiply to this, but it's not like that when you have a coefficient.
It's tiny.
I need to multiply to, not -5, what do I need to multiply to?
Negative 20.
-20. Where'd you get that?
You take
4
the
and
4x
-5.
squared times negative 5.
If you put these together, if you have a coefficient here, you got to put it together. And I need to get to -20. So really quickly, over here, tell me all the ways I can get 20.
2 and 10.
2 and 10, and I heard
5.
4 and 5. That's the only ones I can think of. I want to choose the pair that I can get a 19 out of.
20 and 1.
20 and 1. And if I want positive 19,
20 minus 1.
20 minus 1. So I'm going to go plus 20.
Gosh dang it, that's what I had, but I
Minus
didn't know
1.
what the heck to do.
Now, with the Berry method, we know that this is not going to be 4x and 4x when we're done, because 4x and 4x makes 16x squared. So the last part of the Berry method is, if you can reduce it, you must reduce it. Can you reduce this?
Yeah.
Yeah. What can I divide both these by?
4.
So pull a 4 off. And you pull a 4 off, and I get 4
X plus 5.
plus 5. And then that 4 that I pulled off, this is the only time that you get to undistribute a number, and then poof, throw it away. And then this does not reduce. There's nothing I'm going to divide both those by, so just 4x minus 1. And now, I have my binomials. I want to set each one equal to 0. The first one's going to be a piece of cake. This is going to make x equal what?
Negative 5.
That's one answer. X equals -5. The other one you might want to work out. I'm going to say,
1/4.
yeah, positive 1/4.
I said positive.
Oh, did you? Okay. Oh, I just said negative.
You just said 1/4.
1/4. You are right. It is 4x is 1, so x is 1/4. And there's your answers: -5 or positive 1/4. I got another ugly looking trinomial, and it's like double ugly. Let's talk about what might make something double ugly. Obviously it's quadratic. The good thing is all the pieces are on the left side. What makes this thing a little bit more ugly than a regular one?
Negative coefficient.
Negative, and it has a coefficient. So the coefficient kind of makes it a lot harder. The negative. Now I can fix this negative problem, something that we talked about way back in Algebra 1.
Just flipping all the signs?
Yeah. If you look at an equation, if you would multiply an equation, every piece by -1, you can flip it. So this becomes 16, this becomes -12, this becomes +2, and technically, if I multiply 0 by -1, it's still 0. I am technically doing every piece, but 0, it doesn't change. So, if you have -x squared, my thought, you can do it. If you like to factor with -x squared, be my guest. My suggestion though would be, I don't
Berry
want,
method.
yeah, well, first I don't want -x squared, so I'll just flip it so it's not negative. And now we're going to see about the Berry method. So I'm going to drop this. Inside, because of that coefficient, that's 16, what am I going to put in those parentheses?
16x.
Yeah. And I know that won't be right because I know that's way too big. But we'll figure this out. Two numbers must multiply to,
16 and 2.
yeah, so it's going to multiply to
32.
32. So I'm going to write down here all the ways I can get 32. I'm going to come over here and do it. 32 and 1.
16 and 2.
16, 4 and 8. Anything else? Those are the ones? I think those are the ones. What do we want to get them to add or subtract to?
Negative 12.
-12. So which one might work for us?
4 and 8.
4 and 8. Now if you want to make a 4 and 8 be -12, how are you going to do it? -4, -8. -4, -8. Or, -8, -4. Doesn't matter. Alright, Berry method. Last part of Berry method, if it can reduce, it must be reduced. I can reduce this one by what number?
4.
4. So I'll pull the 4 out, and then it becomes what inside?
4x minus 1.
And then that 4, gone. I can reduce this one by more than 4.
8.
Yeah, I can reduce that by 8. So pull the 8 out and it becomes
2x minus
2x minus
1.
2x minus 1. Yeah,
Yeah.
there it is. And then I just delete those numbers I pulled out as part of the very method process. Delete them. Here's my binomials. Set each one equal to 0 and see what we come up with. So 4x minus 1 is 0. 2x minus 1 equals 0.
1/4 and 1/2.
It's going to be 1/4 and 1/2. Add the 1 over, and 4x is 1. Divide by 4, and x is 1/4. Add the 1 over, and 2x is 1. Divide by 2, and x is 1/2. So there's my numbers. I got x is 1/4, and x is 1/2. Both positive. Both positive. Both good. Now, I'm going to tell you one thing. We are not going to do this next problem. We're going to use this next problem to talk about the future. This is a quadratic. Jeff, how about it?
Because it has x squared.
Because it's got x squared. It doesn't have any x3s, x4s, x5s. That's why it's quadratic. It's an equation because what?
There's an equal sign.
Equal sign. This is a quadratic equation. Now, what we've been doing to solve these quadratic equations, like on the first page, let me take a fresh one. What we've been doing is factoring the trinomial on the left side. Just like this. And this one was not so bad. We would put our parentheses, we put our x's in, and we would factor it. We would unfoil it. If you were going to do this one, right here, I'm going to write it. Don't write it, because we're not going to do it. I'm just going to pretend like we were going to. So, make believe. All right. Is there a coefficient right here? Okay, what do we have to do when you have a coefficient here?
Just bring it there.
Yeah. 3x and 3x. Like I said, don't do it because I'm not going to make it all the way to the end of this. Now, the numbers that go right here and right here don't multiply to 144, as if that's not bad enough. I don't want to figure out all the ways to multiply to 144 myself. They actually have to multiply to what? 3 times 144. What on earth is that? 432. 432. I do not want to sit there and find all the different ways to multiply to 432. Here, the note down here on bottom says, because it might be tedious to find two numbers that multiply to 432, and then they somehow have to add or subtract to what?
-42.
-42. So you've got to list out all the different ways to do it and find the pair that multiplies to -42. We might need something else. And as you can imagine, numbers get bigger than 432. Numbers can get up in the thousands, and you don't want to have to figure out all the way to multiply to some thousands and add to some hundreds. So as these things get bigger, we need another way to solve a quadratic equation. Now we're going to get that. And that's going to be what our next notes are going to talk about. Something that's called the quadratic equation. So I'm going to write what we had. We had 3x squared minus 42x plus 144 equals 0. Now I'm not going to solve it today. I'm just going to tell you what the quadratic equation is and how it helps us. What we do is identify these three pieces and we call them A, B, and C. Like this is A. So A is 3. B is -42 and C is 144. So when you do the quadratic formula, instead of trying to factor or do anything, we're just going to call A, B, C. 3, -42, 144. And then there is this special formula called the quadratic formula, which we were all going to get memorized. And it goes like this. To solve a quadratic, any quadratic, you just say x equals -b plus or minus, so that's how we get two answers, the square root of b squared minus 4ac all over 2a.
Wow.
Now that has to be memorized because that is going to be able to solve every quadratic equation, the ones that we did today and the ones that are going to be harder that you're going to see on Monday. The good thing about it is we've got a song that'll help us learn it, and then we also have a really good story that's going to help us learn it. So on Monday, when we come back, that's what we're going to look at. Quadratic equations, but how to use this formula to solve any quadratic equation.
That just sounds like so much fun, Mr.